Well, thank you for this introduction, although, of course, my Portuguese is not up to the task of understanding actually what you said, but since I know what I sent, I do know what it's about. Yes, actually, I want to say, first of all, thanks to ILSI Brasil for inviting me to give, well, not only this talk, but the next one of the next ones. And also to say that I'm very impressed, actually, by the output of ILSI Brasil. Actually, I should have been more aware of it, being the chair of the Food Allergy Task Force of ILSI Europe, but I wasn't, so I stand corrected there. Also, for the benefit of the translators, I will try to speak not too fast, which is something I have a tendency to do. Well, you have to blame it on my partly French heritage. Anyway, so enough of that. What I'm going to be talking to you about is actually exemptions as they have been implemented in the European Union. I'm not going to say, I mean, there are other legislation, such as the US legislation, FALCPA, does provide for exemptions, but my understanding and knowledge, I think, is that no application so far has been successful, whereas in the European Union, we actually have had success with a number of them. Oh, is this? Ah, right. Next one. Yes, okay. First of all, a little bit of background, actually. The original allergen labeling legislation in the European Union is Directive 2003/89 EC, which is actually an amending directive, as it says there, which made allergen labeling mandatory from the 25th of November 2005. And there is specific provision in that legislation for exemptions. Originally, actually, for temporary exemptions until actually the industry had the time to put in place programs to actually reach temporary, permanent exemptions, provided they had the desire to continue doing so. This particular piece of legislation has now been overtaken, in fact, by Regulation 1169/2011, Food Information for Consumers Regulation, which has been applicable, at least from the allergens point of view. There are lots of other elements within it from the 14th of December 2014. So it's fully in force. So just to go very quickly through the exempted ingredients, you can see how the legislation has been framed. It actually takes the allergenic food and then lists the specific exempted ingredients for that particular allergenic food. So there are exemptions in relation to cereals containing gluten, fish, soybeans, milk, that's mammalian milk, of course, no question of soy milk here, nuts as well. And of course, what you may hopefully be able to read on the bottom there is obviously that products derived from an exempted ingredient are actually deemed to be also exempted, unless there's some reason to believe the contrary. So what was the basis? As I mentioned, the basis was formally set in the legislation, and it says here, concerning Annex 3A, which is the part of the legislation actually which lists the allergenic ingredients as defined in the European Union. It says updating could be effected by deletion from Annex 3A of ingredients for which it's been scientifically established that it's not possible for them to cause adverse reactions. So clearly, the intention is that such exemptions should be based on clear science, and good science, in fact. And yes, it mentions that to this end, the Commission may be notified and so on of studies being currently conducted. That was a part of the temporary exemption process, actually. And the Commission, actually, after a little while, I think, actually provided some guidance, actually, on how to prepare an exemption dossier. And as I mentioned, the initial focus was on temporary exemptions, and that had to be provided by November 2005, if I remember correctly. And then any, depending on the decisions of those preparing the exemptions, further studies could be done if necessary, to obtain a permanent exemption, and that was, the timing for that was before, I seem to remember, November 2007. And yes, EFSA has subsequently developed guidance rather than the Commission services, two different organisms, which I'll talk a bit about later. So, in the original process, it talked about who may be notified, and yes, clearly producers and manufacturers of the derived substances, or foodstuffs, including such substances, or representative associations of those producers and manufacturers. And we had we had examples of each, although in fact for the exemptions I'm going to talk about, the exemptions were prepared, or the dossiers were prepared on behalf of associations. Notably in the case of the soybean oil dossier, which I'll talk about, the FEDIOL, the Seed Crushers and Oil Producers Association, I think it's called, and the Margarine Association of the European Union as well. And then it's what may be notified. Quite clearly it says only the derived ingredients themselves or substances may be notified. So there is no possibility here of notifying that a particular, for instance, infinitesimally small amount of the actual allergenic ingredient can be notified. So there was no point in pursuing that. That was, as some might say, a train which had left the station already. And notification is limited to generic derivatives. So we can, yes, for instance, in the case of soybean oil, we can have soybean neutralized, bleached, and refined and deodorized soybean oil as a category of foodstuff, not a particular manufacturer's soybean oil. Yes, and it says no branded ingredients. So what needed to be in the dossier? Yes, a clear characterization of the ingredient or substance for which the temporary deletion from Annex 3A is sought, as well as the conditions of under which the consumers are exposed to it. So in a way, actually, when you look through that, and if you're familiar with toxicological studies, you can see some of those requirements actually appearing in there. First of all, know what you're actually asking and characterize what you're actually asking for the exemption for. Consider exposure to the consumer, to that material. And then, of course, the important thing, what is the scientific evidence for exemption? Arguments and data that support the claim that the ingredient is not likely to trigger adverse reactions. And in the case of temporary exemptions, actually, as I say, the first part of the first step, an overall description of the studies that the applicant is conducting. And in fact, the opinions that came back after the original temporary exemptions were described actually where the European Food Safety Authority thought that the exemptions were lacking in sufficient substantiation. So, after this little bit of background on how we proceeded through the exemptions, I'm going to take you through two dossiers, as I mentioned. One is the highly refined soybean oil dossier. The other one is wheat-derived glucose syrups, which is another one. I was personally involved, actually, in the development of this particular dossier, so I can answer more details about that one than about the next one, but you will see anyway. We'll see how we go. So, what was in the soybean oil dossier? Well, first of all, this is the permanent dossier. I'm not going to go through the details of the temporary dossier here. So, background was a recapitulation of the temporary exemption dossier. So, actually, what had we already said, and what arguments had we put forward to indicate that refined soybean oil should actually be exempted? Then analysis of the published data based on fully documented literature search, and we had to describe things like the search strategy that was explicitly required, and then of course the initial EFSA conclusion in the form of the opinion which they issued after receiving the dossier and analyzing it. Then, characterization of the materials. We're going through the points which I mentioned before. the oils refining according to Fediol specifications. During the process, actually, Fediol developed a code of practice, in fact, for oil refining, which was implemented and is considered good practice within the European Union and hopefully beyond as well. Then we looked at quantitative protein extraction and analytical methods specifically developed because, as you may well know, oils are not, protein measurements in oil are not easy to make, particularly actually when you're coming to very highly refined oils, because there isn't much of it, and the proteins are quite difficult to extract. And then we looked at the Ig binding characteristics of the extracted proteins. And another element, actually, and I would say that probably accounted for the bulk of the expense of putting together the dossier, as you can expect, clinical research. And there we went for the gold standard, double-blind placebo-controlled food challenges in peanut and soy allergic individuals. Why peanut allergic individuals? Because EFSA suggested that because of the similarity, I mean, the potential cross-reactivity, they wanted to see those sort of data. Of course, those have to be done in characterized patients, and so we did a full allergological screen for them. And then soybean oil or rapeseed oil as the placebo was mixed with mashed potato, and I will describe those studies. And for the exposure assessment, we just did a worst-case scenario. You will see actually that what we did differs from what was done for glucose syrups, where they approached it in a different manner. So, conclusions from previously published work. Probably know that highly refined soybean oils and most other highly refined oils, actually, edible vegetable oils, contain very small amounts of protein. We're talking about less than 1 ppm, actually, in most cases. And you can see in the diagram here how they decrease as a consequence of the refining process. Ig binding, and these are from previous research, Ig binding was only observed with a single sample of unrefined soybean oil, which contains considerably more, as you can see, protein than the refined one. Allergic reactions to soy require relatively large amounts of protein, certainly not of the order that we find in any edible amount of oil. And controlled clinical challenge studies show that soybean oil was unable to provoke reactions in individuals with well-documented soybean allergy. And those studies actually were done, in fact, by Steve Taylor originally in the early 1980s. So, characterization of soybean oil. We obtained a number of soybean oil samples from different refiners all across Europe. I mean, there are several big refiners. And those were oils produced according to the code of practice that I mentioned. And you can see here the actual figures. We've got that. Crude soybean oil, 87 micrograms, 87 ppm, so 87,000 nanograms per gram. Fully refined soybean oil, 250 nanograms per gram, so less than 1 ppm. And the ones, strangely enough, the ones that we used for challenge were even lower. So, I mean, a lot of the results we got actually were non-detectables as well when we looked at all those samples. So it's not surprising. We looked at characterizing the protein using mass spectrometry in collaboration with the Institute of Food Research in Norwich with Claire Mills's group. And we also looked at identification of Ig binding proteins by immunoblotting. And basically you can see the results here. Oops, I've gone back there. It's the wrong thing I wanted to show. Lanes 4 and 5, yes, 5 and 6 are neutralized, refined, bleached, highly refined oil. And you can see that there's nothing there. Right, okay. Now, to come to the clinical research, I'll take that in fairly slowly. We managed to find 30 peanut allergic individuals. You can see the age range there, and the distribution among the genders. All with a positive peanut double-blind placebo-controlled food challenge, of course. I've already mentioned, okay, and in addition to those 30 people, with peanut allergy, we managed to find 32 soy allergic individuals, roughly the same distribution of ages, slightly more biased I see towards females there, with a positive soy double-blind placebo-controlled food challenge. And we used the following materials. The active was obviously the neutralized, refined, bleached, deodorized soybean oil, so the highly refined soybean oil. The placebo was canola oil, as I mentioned before. And what we used was an escalating dose protocol, starting with a low dose, 12 mils of, dose 1 had 12 mils of oil in about 100 and 150 grams of mashed potato. And it goes up for dose 3. We didn't do too many intermediates there. Up to 48 mils in about 200 to 400. So if nothing else, actually, by the time the challenge was finished, the people who'd taken part actually were feeling pretty full, if nothing else. Their stomach was certainly full. And what were the results? Well, 28 completed the full challenge with soy oil and 27 with canola oil. And the remainder stopped because of fullness. You can see why. If you want to try it for yourself there. The reactions were all, so we did get reactions, but they were all subjective and mild. We had 22 people out of 30, so it's a peanut individuals, who had no reaction at all. Soy oil only 2 out of 30, placebo only 4 out of 30, and both soy and placebo 2 out of 30. And after analysis of those results, actually, we concluded that, in fact, because of the equivalence between the placebo and the active there, or the reactions observed in the two groups, actually, the reactions were not significant. Okay, so now looking at moving on from the peanut allergic ones who'd been challenged with soy oil, we did the same thing exactly with the soy allergics, obviously, and again, same protocol. 31 actually, so one more actually, well, more completed the full challenge with soy oil, and 32 with the rapeseed oil. And again, one stopped because of fullness. Don't know why they made a distinction there. Again, similar pattern to with the peanut oil, no, with the peanut people rather, peanut reactive people. And again, similar pattern of response, no reaction, 21 out of 32. Soy oil only 3 out of 32. We actually, in this particular case, got more people responding to the placebo, and both soy and placebo, 2 out of 32. So again, when we did the statistical analysis, there was no difference in the incidence of reactions between active and placebo groups. And we concluded, therefore, that we did not have reactions to soybean oil, to highly refined soybean oil. Now, looking at the exposure assessment, and I don't know what's happened to the slide, somehow seems to have moved to the left. We used, as I said, a worst-case scenario, and we really went to town on that particular worst-case scenario. Now, things, and we, because we were actually in Brussels at the time, where Fediol and Demasset and so on, with whom we were developing the dossier, actually are in Brussels, as is indeed ILSI Europe. We looked to see what Belgians eat. Well, they like plenty of salad dressing on top of French fries. They like French fries enormously. They like mayonnaise as well. So we decided, okay, well, and margarine as well to go with it. And we sort of came up with a total exposure of 80.5 grams of oil as a single, in a single serving, a single meal, and which would contain, actually, according to the protein concentration measurements, 12.1 micrograms. Just as an illustration, actually, the Vital 2 reference dose, which you'll hear more about today, for soy is actually 1 milligram, so 1,000 micrograms of soy protein. So nearly 100 times more. And the worst-case scenario, by definition, vastly overestimates likely exposure, even in Belgium, using eating those particular foods. And, oh, we're missing some of that. That's a pity, actually. But anyway, this is the conclusion of the EFSA panel who reviewed the dossier, who produced the opinion. And they say, taking into account all the available information, it's useful to read it out, the panel considers it is not very likely that neutralized refined bleached deodorized soybean oils will trigger the severe allergic reaction in susceptible individuals under the conditions of production and use stated by the applicant. They used interesting wording there, but that was considered, yes, that they were happy with it. The Commission decided, because EFSA are the risk assessors in Europe, the Commission actually, in the shape of DG Santé, the Directorate General for Health, are the risk managers, and they concluded that's fine, it can be exempted. So that was the soybean oil dossier. Now, looking at the next one, wheat starch hydrolysates. As I mentioned, that was that dossier was prepared and submitted by the starch people. I can't remember what the initial stands for at the moment. Actually, they change. I think they've anyway changed it to something like Starch Europe or something of that nature, a more modern-sounding name, I suppose. I was not directly involved, but I do know the person pretty well, actually, as he was also a member of the Food Allergy Task Force, who was primarily involved in producing this dossier. So again, the file contents follows the same pattern. I mean, that's a good dossier should normally follow recommendations for preparation. It does help acceptance. So literature review, code of good practice on purification of wheat starch hydrolysates, then analytical studies, exposure assessment, and clinical studies, all reviewed externally. I can easily. So to guarantee consistency in time and throughout it, well, the purpose of the code of practice is really similar to the one we developed for soybean oil, oil refining, actually. And that's to guarantee consistency in time and throughout industry, and to demonstrate industry commitment, actually, to in quality management systems. And what the new quality parameter defined to guarantee maximum residual gluten content was initially 100 ppm, changed later, actually, and yeah, finally set to a maximum of 20 ppm based on the R5 ELISA. You have to remember that this was actually before the 20 ppm limit was actually recommended by Codex, and then subsequently, almost instantly, incorporated into a regulation in the European Union. So, yes, considerations that needed to be taken into account in terms of analysis. Well, the high carbohydrate matrix, there was low residual protein or gluten content. There are other sources, like phospholipids, which are non-protein nitrogen constituents, and the residual protein gluten is expected to be partially hydrolyzed as a result of the manufacturing process. So a variety of analytical processes were required here. So initially, nitrogen content by an adapted Kjeldahl methodology. That had to be adapted, obviously, for such low concentrations. And then it was noticed that the nitrogen content was mainly explained by the presence of phospholipid residues, as I mentioned, and less than 100 ppm true protein was the limit of detection with direct HPLC amino acid analysis here. So the true protein content, actually, if you just looked at the nitrogen measurement, was highly overestimated. Now, in terms of structural characterization, number of techniques again, extraction and concentration protocol were based on reverse phase chromatography, and good recovery was obtained there. Different approaches, including mass spectrometry, well, based on mass spectrometry, and then some semi-quantification by use of different calibrators and internal standards. And trace amounts of native gliadin, 1 to 15 ppm, and gliadin glutenin peptides, 0.5 to 10 ppm, commonly present in the materials analyzed. So in terms of the immunochemical determination of residual gluten, the R5 ELISA, which had actually been developed during that particular period, as part of the work, actually, I think, of the Prolamin working group by Mendez in Spain, it detected presence of hydrolyzed protein, both in sandwich, 3.1 ppm, and competitive R5 ELISA were used. Industry samples taken between 2004 and 2006 were mainly a bit below the detection limit, but occasionally above the 20 ppm gluten limit. And the study samples are mainly below the detection limit, all below 5 ppm. And no higher levels were detected with the competitive R5 ELISA either. So in terms of the, obviously there was interest because, of course, when we're looking at the, this particular dossier, you have to consider two aspects. One actually is protection of people with celiac disease, and the other is protection of people with wheat allergy. So we needed to look at both aspects here. And this is specifically concerns the celiac side of things. And Fritz Koenig, who is an expert on the toxic peptides from gluten, and I think he can just name them out of the top of his head, actually, if I remember correctly, was approached to do this particular work. He did a T-cell, well, basically T-cells-based assay, looked to see whether actually the peptides actually stimulated T-cells in relevant individuals, but that particular assay is actually quite limited, quite difficult to standardize, as many cell-based assays are, and it had limited use there. And then monoclonal antibody assays were developed as well, calibrated with the European gliadin standard, and the highest results were obtained with gliadin gamma-1 monoclonal antibody. And again, yeah, the study samples are mainly below the 5 ppm and all below the 12 ppm gluten. And of course, monoclonal antibodies against low molecular weight and high molecular weight glutenin epitopes were calibrated with synthetic peptides. But of course, as you'll realize there, because of the way that the assay was developed, you can't actually translate that to a particular concentration. HPLC amino acid analysis was done based on reverse phase chromatography, and again, limited data. Again, 0.5 to 1.4 ppm were detected there, based on the amino acid content. So, to conclude on the analytical side, taking into account the complexity of the problem, which seems to have been even greater than with the highly refined soybean oil, the best available technologies were used. They were based on immunological and HPLC data. We could say actually study samples all below 12 ppm, and industry samples mostly below detection limit, which is where we want them to be, and occasionally against above 20 ppm. And industry actually committed itself, as I said, before the codex actually came out with that figure, to a maximum of 20 ppm gluten, and also to further optimize refining if necessary. So, looking at exposure, so this is the consumer side of things. How much are they being exposed to? They used food consumption based on Ireland, Italy, and the Netherlands. All countries actually which do actually have an issue with celiac disease, I think. And the main applications areas are based on AAF data. That's the choice. And the total population and population groups are looked at, and both daily and single meal daily consumption is considered. That's to reflect the risk to people with celiac disease, and then single meal occasions for people with wheat allergy, because as you know, that is the part that is the relevant metric when you're looking at allergy, how much people are exposed to on any one occasion, not throughout the day or the year or whatever. And yes, realistic and worst case scenarios were also developed. So in this particular case, the daily exposure, the worst case, so that's the 95th percentile, was 4.3 milligrams, and single meal exposure was 1.7 milligrams as a 95th percentile. So those are the ones for wheat allergy. Well, celiac disease and wheat allergy, respectively. Now, 2 double-blind placebo-controlled food challenge studies were done. One in respect of celiac disease and wheat allergy. Obviously, there had to be 2 since there were different populations. And both wheat-based glucose syrup and maltodextrin were separately evaluated. And the same type of product for glucose syrup, maltodextrin and placebo group. And yes, taking into account, of course, the dose actually took into account the exposure data, which I've already mentioned. And for celiac disease, of course, the exposure period needed to be longer than for, because you wouldn't necessarily, particularly at those levels, you would not expect to see a change in the patients over a very short period of time. And yeah, small-scale production of the materials was actually done in according to food industry standards. So, as I say, a more complex episode. And it was presented as a powdered soft drink in single-dose sachets in 2 flavors, adjusted to the same sweetness level, so by the use of sucrose and 10 sweeteners. So, technically, again, quite challenging. So, looking at the celiac disease study, 90 well-characterized celiac disease patients on a gluten-free diet, so stable and not experiencing symptoms at the time. They were randomized into the 3 groups as indicated there, and the study went on for 24 weeks. Of course, it was not a study where they would go into a clinic. They would have to do that at home. And the parameters are evaluated as the ones you would normally look for when you're looking to diagnose celiac disease. The interesting thing is actually, yes, they were obviously must have been very well motivated because there was good compliance to the study protocol and not too many premature withdrawals, actually. And there was no significant difference between the product and the placebo groups at the end of the study, which is good. So that celiac disease aspect was sorted that way. Now, looking at the wheat allergy seems to have been more complex than one might have expected, actually, in this context. They aimed to enroll 60 individuals with clinically proven wheat allergy. They randomized them into 2 product groups, and they did a 2-day double-blind placebo-controlled food challenge in clinic. So that would be active on one day, placebo on the next day, whereas with the soybean oil, actually, because of the shorter protocol, we were able to do both on both days, on the same day. And then they did 20 days reintroduction at home as well. So again, parameters were the clinical symptoms typical for food allergy. So at the end of the day, despite aiming for 60 patients, we ended up with 36 patients and 32 completing the study, so about half, really. Yeah, some just refused to participate, which is entirely within their right, but unfortunate. And children under the age of 2 years, who actually are some of the prime candidates, actually were not allowed to participate anyway for ethical reasons. The 2 days challenge at clinic demonstrated limited symptoms and no significant difference between product and placebo. So essentially the same sort of results as we had with the highly refined soybean oil, in fact, if you think about it. But the 20 days challenge produced a high rate at home, produced a high rate of symptoms, but yeah, both the product and placebo. But it is very difficult to interpret those particular results under those conditions. And of course, what the people were reacting to may not even have been the materials that they were tested with there. So, to summarize and finish this particular one, the EFSA final opinion, issued on the 3rd of May 2007, said that in respect of celiac disease, you can read here, wheat-based glucose syrups and so on are unlikely to cause an adverse reaction in individuals with celiac disease, provided that the provisional value of gluten considered by Codex Alimentarius for foods rendered gluten-free is not exceeded. So that was the 20 ppm limit that I referred to, which Codex had been working on for a long time, shall we say. In respect of wheat allergy, you can read the whole of the conclusion there, but the last sentence, the last part actually, the panel considered it is not very likely that this product will trigger a severe allergic reaction in susceptible individuals. So on that particular basis, the wheat-based glucose syrups and maltodextrins and a few other similar products were exempted. And since that time, actually, we know that the exemptions actually for the same materials actually have been accepted by fazans in Australia and New Zealand as well, on the basis of the same data, because, yes, I mean, we put the case that, yeah, these have been thoroughly evaluated. So you can see it's quite a thorough process. Now, where do we go from here? Okay, I mentioned that there is new guidance. Now, no new applications for exemption have been made since that initial period, but it is still possible to make them. And on that particular basis, EFSA actually produced some guidance, updating the guidance that I introduced to you earlier on. Yes, as I say, the purpose of the guidance, to update the Commission guidelines, yes, and help applicants prepare well-structured applications, provide a common format for the organization of the information. Obviously, that makes it easy for the panels to go through it, outline the required information, describe the hierarchy of different types of data and study designs. And this guidance is freely available from EFSA anyway, publicly available, and it's well worth looking at. So what is required? To allow scientific evaluation, the application must contain information on the characteristics, of course, all pertinent scientific data. So you've got to actually provide, well, identify the data which are supportive of the application, but also identify any data which might not support it, and put that in there, argue the case about that. We did that actually in the refined soybean oil dossier, as it happens. Yes, and where any of the required data are not relevant, and so on for particular reason, justifications must be given for absence. And then pertinent published human data should be identified through a comprehensive review. What type of data are required? Food challenge studies, yeah, may provide important information. So those are the ones that are not conducted specifically for that particular purpose. And then double-blind placebo-controlled food challenges are less subject to bias, so they like those. You see that, I mean, all fairly straightforward. Emphasis again on the characterization of the study population. Well, that's, I think, is fairly self-evident. And that sample size should be adequately justified also within the context of the application. And they do state actually one they make one particular point, that studies in animals or other model systems alone cannot substitute for human data. They may be able to provide additional data, but you will never get an exemption just through those data. Oh, that's it, basically. So I hope that was instructive there.